We'd like to talk about WaKaYo IoT solution for the Ruby mruby/C. The manufacturer for the development is a Techno project. Introduce the presenters from the Techno project. My name is Yuya Hayashi. I studied physics and then joined the Techno project. And then for 4 years I worked as an IT engineer and IoT device development, and I am in charge of the IoT device development and processing of data. I am Takeuchi. I've worked as software development and created a company. And from the Techno project, we have the consignment project for the development of WaKaYo. And I am in charge of the server structure, server-side functional development. I would like to start the presentation. This is the agenda item, the function of WaKaYo and the process of development. And I would like to talk about IoT device overview, the function of WaKaYo. There's the 2 minutes video, and please enjoy it.
続いて開発の経緯を述べていき
Now, I'd
ま
like
す。
to talk
発端
about
は
the
我々テクノ
development
プロジェク
of
ト。
the processes. As a course I took, this is a joint project. The measurement of the indoor, the room environment, and with the measurement is done for the development of our sensors and CO2 measurement equipment and the VOC PM 2.5 part of our research project for the further development and the research. And with the expansion of the coronavirus, we have to avoid the close contact of the people. And first, there was regulation very general. In order to avoid the infection, we have to avoid ventilation loss. And based upon this, we started the joint development. And first of all, systems should have been development, so we determine the requirements. This is the system requirements. First of all, for the measurement of the air, the conditions related to CO2 and humidity and the temperature are measured. And also, because of the degradation of the indoor environment, and we wanted to create a device that could detect these anomalies, and based upon the findings, the CO2 should be measured at the interval of 1 minute, and the measurement is decided at 1 minute interval. And but the system requires the frequent access to the servers at about 1,000 access per minute, and also there is user access in addition to that. Therefore, this kind of a transmission would accumulate to 500 million, and the problem was to solve this frequent access and huge amount of data. Therefore, we try to figure out a configuration that would enable this, the system requirements, system configuration. And first of all, AWS is selected, and the IoT device, mruby is used for the efficiency of the development, and the Ruby on Rails are used on the server side as well. For the details, I'd like to explain to you later. First of all, the overview of IoT device. Left-hand side, you see the hardware, the configuration, and in the middle, this is a microcomputer, and this controlled other the modules, and this is the Wi-Fi module with the LED and room air monitor, and also there are some other the condensers and the register to minimize the noise, but this is not relevant. The software on the right-hand side, exciting, and on the mruby, and virtual machine is on this, and hardware abstraction, and the functions are mounted, and mruby/c is mounted on top of that. This is the target of the development this time, and with mruby-c, we were able to achieve a higher efficiency, and the C code and mruby-c code compared directly to WaKaYo. We didn't develop this code for this purpose, but the significance and the semantics are the same. You see, this is more efficient. It is possible because, first of all, this is a virtual machine, and the major module are defined, and also the grammatically it is succinctly written, and in addition, this is very important. We do not get into the trap of this, the C language, and therefore we were able to develop more efficiently and at high speed. And I'd like to explain that in more detail. This is a cycle of the development process. IoT device is developed with the hardware development first, and then based upon the specifications of the hardware, software is developed. Then we would use the real machine to test it, and if you find some test, then we would go to the hardware and the software, and there will be some restriction of the feedback. For instance, Wi-Fi. For instance, there was a potential of the aberration of the temperature reading because of the heat generation. Therefore, we have to have the distance with the Wi-Fi module. And also, Wi-Fi module had a bug to stop the device, and therefore we needed to modify the software codes. And therefore, if you find one problem, you have to look at both hardware and the software, and you have to modify, and hardware and location, and the revision would require also the revision of the software. I didn't write this, but the sensor was not available. Therefore, we needed to recall the gather hardware, and if there should be some problem of the measurement, we have there is a possibility of causing the modification of hardware and software. Therefore, it is very good to use mruby C instead of C language. I would like to explain the server side. Now, CO2 data come from the IoT, and we expected a huge amount of data. Therefore, Amazon EC2 was selected. Therefore, the one day data is put on the EC2, Amazon EC2, and then sent to AWS CLI. And therefore, it is divided between sensors and put into Amazon S3. Therefore, we were able to handle huge amount of data. Now, the day's data is put on the EC2 local data CSV, and for the past data through the AWS Lambda will get the data. And at Lambda, there will be some the cutting some data off so as to reduce amount of transmission of the data to reduce the load upon EC2 Amazon. Now this is a Webpacker for the setline Webpacker. Makes it easier to use a Webpacker. This is a library, and the static cell JavaScript framework introduction was introduced very smoothly. Then the reciprocate is used for the cassette pipeline, and we have used this for development. But recently, the URL of the front line is richer today. Therefore, we decided instead to use a Webpacker. Now, we divide the front line and the server side, and Webpack is quite useful. Therefore, for the development of a Webpack, this is very convenient to have the interaction through Webpacker to the front end, and Vue.js use tools, and the Bootstrap for CLS, and this is divided between users and administrator, and the user function is used for Vue, and the administrator uses Bootstrap, and the router is not used, and the Rails routing is used instead for the router. And the single page application is not used here. This part of the image is supported by Vue.js and very effective. And the asset compile is done by Rails, and for Java CSS, the specific method is prepared. Therefore, it was very convenient. Now, active job. Now, background job is controlled through the Rails, and this is a command. The background, and for the release is used for the perpetuation of the data, and the system D is used in addition to that. For this system, mail transmission, the small light on and off, and the API, these are put into the background job. Mail is used for mail, CO2 alert and heat shock alert, and Amazon CSS is used. And for the light on and off is supported by API using Lambda. By using active job, you don't have to directly handle but the registered jobs. Therefore, it is possible easily to change over to other job schedule. And therefore, Web and Ruby on Rails are used to develop very efficiently, and the development time was minimized. Now, with the expansion of the coronavirus infection, we developed the system to visualize the indoor air environment. IoT device, web applications are developed with Ruby. With a lot of efficiency and using AWS, the huge amount of data and the server-side load reduction were sustained. Into the future, various sensors can be added to IoT device for better visualization, and analysis are under study. We are trying to do it on the server side. In addition to the coronavirus, we would like to expand application to the QOL and the health promotion. Thank you very much for your attention.